Hey guys, this is Mr. Oliver. I'm going to go over the solutions for AP Physics 2, Unit 5 free response question number 2. Alright, so let's go and get to it. Alright, so for this first question, we have a particle of charge positive Q moving to the right at speed v naught. It's going to go into this region where there's going to be a field. And the field is a constant and uniform field. The effects of gravity are negligible. Now the first question says, on the figure below, draw a possible path of the particle in the region if it only contains an electric field directed towards the bottom of the page. So if I sketch that out a little bit bigger so we can see it here, if I've got this region that has an electric field that points towards the bottom of the page and it's uniform, then what that means is that up here at the top is that this is a positively charged region. Down here towards the bottom, this is negatively charged. And so if I get this particle, which it says is positive Q naught, that moves in from left to right, then as soon as it hits this boundary, it's going to start to experience a force due to this electric field. And because that's positively charged, it goes, that magnetic or that electric force points in the same direction that the electric field points. In other words, this positive is attracted to these negatives down here. And so what it is this pathway is going to curve downwards, almost like a projectile. Because if you remember, in projectile motion, they're accelerated towards the ground by a constant force. Well, this electric force is a constant force the entire time. Horizontally, it doesn't speed up. It only speeds up or slows down in the vertical. And so this pathway is parabolic. Has a parabolic arc as it travels through there. And this is for part AI. All right. Now, the same question is asked for AII, but this time the field has magnetic, or the area has a magnetic field. Okay, same region. We turn off the electric field and we turn on a magnetic field, and this time the magnetic field is pointed out of the page. So we get these little dots for out of the page. It's uniform, so we have the nice little even spacing of the dots. And we still have that charged particle, but this time it is moving through a magnetic field. All right, so what's going to happen here is, let's look at it right as it enters. As soon as it enters, we've got a particle moving to the right. So you put your thumb in the direction of the right. Magnetic field points out of the page. And so that means that your force is coming away from the palm of your hand. And so that magnetic force points down. And just like we've done before, anytime you have this magnetic force with a charge, the pathway is produced by this magnetic force is a circular arc. And so in this case, the pathway won't be a parabolic. It's actually going to curve as a portion of a circle. So you can almost imagine, depending on what you drew here, that this circular arc, okay, that's pretty close. Let's do it like this. Okay, I didn't draw very good. But you can imagine, if this is a compass, that pathway would be circular rather than parabolic. Okay, the way they grade this is that they interpret it's like, well, is this curvature more than this curvature? And so in this case, you got to make it curvier because it's more circular than parabolic for the second one. Okay, now the last part of the question says, for which of the previous situations is the motion more similar to that of a projectile and only a gravitational field, and why? Well, that's going to be the electric field. And the reason why it's more similar is because the electric force is constant, pointing down. Force is constant, the electric force is constant, pointing down, just like gravity is constant, pointing down. as opposed to the magnetic force, which is constant but points towards the center of a circle, which is the centripetal force. Okay. And then the last part of this question is a paragraph length response. Let me highlight and kind of point out the things that you need to know on this. Here we've got another region of space that contains both the electric and the magnetic fields. Okay, so here's my electric field, but this time the electric field is pointed towards the top. So I'm going to accentuate the drawing here. So there's my electric field. Magnetic field is out of the page, and they even say it right here. This is out of the page. Be out. And it says a horizontal beam of protons with a variety of speeds enters the region. So you got some particles that are moving really fast and they're kind of moving slow, but they're all protons. They're all positively charged. Now it says protons exit the region at a variety of locations, including points 1 and 2. So you're going to have protons shooting all over the place, but sometimes they come up here to 1, and sometimes they come over here to 2. In a coherent paragraph length response, explain why some protons exit the region at point 1 and others exit at point 2. Use physics principles to explain your reasoning. All right, so what you need to state, and there's specific things you need to state on this, is you need to say, initially the electric and magnetic forces act in exactly the opposite directions. So on this left side of this field, right here when they first enter, the electric force on these protons would be up, and the magnetic force would be straight down. So initially, the electric force, and I'm going to abbreviate to save some time, initially the electric force and the magnetic force are same magnitude, opposite directions. The electric force is up, and magnetic force is down. Okay, so that's something critical that you need to make sure you state somewhere in your paragraph. Then you need to say the electric force is not affected by the speed of the protons. Remember in the problem statement it says that the protons are coming in at varying speeds. Well, that magnetic or that electric force doesn't care about how fast they're going. So that means that the electric force stays constant. Stays constant. That's kind of critical. Okay. But then you need to also say the magnetic force is affected by the speed. So it will vary. Sometimes the magnetic force is strong, sometimes weak, depending on how fast the particles are moving. All right, so that means that slower protons will experience less magnetic force and the electric force dominates and directs them up, directs the protons up. And so what that means is that the ones that are going slow are exiting on this top edge over here, closer to 1. And then you also need to say the faster protons experience more magnetic force and the magnetic force dominates and directs it down. And so those are the minimum things that they're looking for in this particular paragraph. You also needed to write it as a paragraph. You needed to write it logically, make sure you don't contradict yourself. But if you concluded all those points, you would have gotten full credit for that paragraph length response. All right, so guys, that's the last for response question. And as soon as you conclude that, that's actually the last one that you'll have to do for participate, or that's the last one available for participation for AP Physics 2. Guys, if you have any questions, please shoot me an email and I'll be glad to help you out. Thanks a lot. Bye-bye.